There, that's working. Okay. In
What is
okay. So we're at degree 3. Degree 3 goes along with linear functions. Yep. I know. I'm just skipping them. They're just review of the same thing. So the cubic function is a polynomial of degree 3. The graphs of two cubic functions are given below. So it still follows the same rules as before. If you have a positive leading coefficient, which these do, they have a positive 1 in front of both of them, I'm going to end up on the right. Correct? My back number, back here, gives me my y-intercept. Now, this throws people off. They'll say my y, well, that's 2, because they count 2 lines and they assume that 2 lines would mean 2. They don't have to make every single line always be 1, right? That's your y scale. If you look here, 4 lines are 2, so 2 lines would be 1. Okay? All right. So how can we tell from there which is actually the correct equation? Plug in your calculator. So let's practice that. So if we're going to put this one in, follow along, please. So you want to see if this equation matches this, right? So what we're going to do is we're going to go to our y equals, and we're going to type that in first. There, what's in there? So you get x cubed. So you do x, little hat symbol, that gets you the cubed. Minus 4x, you could do the little hat in 2, or you could press this little x squared over here. It'll work out. Plus 3x plus 1. Now remember, everyone should be typing this into their calculators, because just because I can do it doesn't mean you can. And I'm not writing your test for you. So you have to do it. Now, the best way to compare a graph is to actually set, if they give you a graph and they give you equations and they ask which equation represents which graph, the best way to actually figure it out to make sure that they're the exact same is to change your window to be the window of their graph so that it will look exactly the same. So right now, my window's not the same. So if I press graph, I get that, and you can say, yeah, they look like they're the same, possibly. But you don't know for sure if they are. So set your window to be the exact same as the window on the test. So this one is from -1 x to 3. So I'm going to go from -1 to 3. And then each little tick is 1. So I'm going to make my x scale stay at 1. And my y minimum, this looks like -1, -2, -3. This must be -4. It's kind of a weird tick. That is strange. So it goes down to -4. It's just off. So go -4. And then y max would be 2, 3, 4, 5. And then they go up by 0.5s, right? Then press graph. So once you have your window to be the same window as what they have, then press graph. So theirs just curves up a little bit more. But okay? So that's how you can type them in to actually see them, correct? Okay. These two graphs have similar end behaviors, but in between the graphs have different characteristics. The graph of P of X has this one. This is P of X, that's Q of X. The graph of P of X has 2 turning points. It has a maximum turning point and a minimum turning point. Let's find out what those points are. Because up until now, all we've had to find was either just a maximum or a minimum, or if it was a straight line, there wasn't one. There was no turning point. Okay? So I want to find the maximum first. So I'm going to go second, trace, maybe, maximum. Which one of these is the maximum? The one on the left or the one on the right? Left, because it's like a hill, right? So it says left bound, so we need to be on the left side of it. Somewhere on the left. I could be here or way down here, still on the left. Hit enter. And it says right bound. So somewhere on the right. Enter. Enter. So the highest this graph goes is 1.6. Now, is that an actual absolute maximum of this graph? No, it's just a maximum point, but the graph actually keeps going, right? Like this arrow actually keeps going forever. Whereas an actual quadratic, if you have a maximum, that is the physical maximum of the graph. It doesn't go any higher, right? So what people try and tell me is that this, for range, they'll say y is less than or equal to 1.63. The range of this graph, you have an arrow going down and an arrow going up. And whenever you have an arrow going down and an arrow going up, your range is YER. So that's why for odd functions, odd functions meaning degree 1 and degree 3, you always have an arrow going in opposite directions. So you always have YER, unless it's a word problem, right? Remember I told you word problems, it changes. Okay, let's find the minimum now. Second, trace, minimum. Now I need to be on the left side of the minimum somewhere. Don't go like way over here and be on the left side of the maximum. Like, be like close to the minimum at least. Sometimes it won't calculate it if you don't. So enter, and then the right-hand side of the minimum. It's a party. It's like a house party. Okay. No. So this would be negative 1.1 is as low as it goes. Okay? So this has a max or a min. So degree 3 functions can have a max or a min, or a max and a min, sorry. Or this one here doesn't have a max or a min. It actually has a point of inflection. This right here is called a point of inflection. So the graph inflects, so it's going with a positive, like it's going with one slope going up, hits that point, and then it goes back up again. So it's like positive slope to positive slope. It's called a point of inflection. So that one doesn't have a max nor a min. It just has a point of inflection. So if you went to go try and find a max or min with your calculator, it wouldn't work. Okay? So here it says, the graph of cube x does not have any turning points, but at C, the curvature of the graph changes. This point C is called a point of inflection. Okay? So, consider the following cubic functions, write in expanded form and in fully factored form. Graph each function on your calculator using this window. So this, whenever they give you windows like this is x min, x max, x scale, y min, y max, y scale. They give them in the order of your calculator too, so you don't really have to load it. Then you're going to type them in and you're going to sketch them. Okay? So we'll sketch the first one together. So let's go to our window and change it. Zoom 6 resets it to negative 10, 10, negative 10, 10. But we don't want that. We want Zoom 6 yet. But we want negative 2, 4, 1, and then negative 5, 7, 1. Then I'm going to go to my y equals, and I'm going to type that one in. So x cubed minus 3x squared plus x plus 5. Now, what do we know about this function? It has a positive x cubed, so where is it going to end on the right? Up. It has a positive 5 at the back, so it has a y-intercept at 5. We very much at least know that, right? Now, this form here can get you other stuff, but when there's no brackets, this top form that has no brackets called standard form, you have a 1 in front of here, so your positive leading coefficient, so it ends up on the right, and a positive 5, so your y-intercept is 5. We know that at the very least. So, how am I going to accurately sketch this? Well, I'm going to have to get the max and the min, right? At the very least. So I can go second trace maximum. Be on the left side of it. Right side of it. So that points at 0.18 and 5. So 0.18 and 5.0. So it's going to be kind of here. Then we also have one going through the y-intercept at negative 5, right? I'm going to get my minimum. second trace min. So it's at 1.8 and 2.9. Kind of around there. What else would help me draw this? I have a y-intercept, I have my max, I have my min, my x-intercept. Do you remember how to find your x-intercepts? Second trace number 2. Now, the left bound, right bound usually throws people off. So if you draw yourself a vertical line through your x-intercept here, what part of that x-intercept is on the left? The bottom or the top? The bottom. And if I draw a vertical line through here, what part's on the right? The top. So it wants the left bound of that x-intercept. I'm going to get a year older by the time this is getting. Enter, right bound of it. Enter, enter. Ah, it's a -1. So please let yours be drawn a little bit better than mine. Now, if I wanted this to actually be even more accurate over here, what I could do is I could find the y value for an x over there. Paying attention so you can figure it out. So I want a y value for an x over here. So I went to 1.8. So say I put in x equals 2, right? Let's see. So how do I find out, where's the only place I can type into x equals? Second trace value, number 1. If I put in x equals 2, it tells me y equals 3. So at 2, I'm at 3. And if I put in 3, second trace value 3, I get 8, but it's way out, right? It's up here somewhere. Well, how else could I find other points on my graph without going second trace value? Second graph. Gives me all the tables. It gives me all the rest of the points that aren't decimals on it, right? So I could pick any points on here and graph better. Okay? So that's my first graph. I want you guys to graph the other two, g of x and h of x on here. So do that. Okay, shh. So if we were to graph this one, this one starts through here, but it's through. Okay, this is another thing I want you to know. If you see this ever on your calculator, e to the -6, what did I tell you before? What does that mean? No. That means 10 to the -6, yes. So that means that that is 0.502052. What could we round that to? 0.50. It's just 0. So whenever you see e to the -6, that is just 0. Watch yourself, because some people will go and plot this at -2 and 4 then. Okay? And then they're like, but that doesn't match the graph. They're like, I must just be reading it wrong or something. E to the -6 just means 0. E to the -10, e to the -7. If you see anything like that, that's just 0, because all that means is there's 5 zeros before this, so we're going to round it to 0. Okay? So it's at 0 and 4. And then your minimum is at 2. That one does that. Because it's at 2. I would check it. If it was on an actual test, I would make sure to find a minimum to make sure it actually is 2 and not like 2.1 or something. Oh. Okay, and then the other one is going to be x cubed minus 3x squared possibly minus x plus 3. And so this one is here. Ooh, this is bad. This is very bad. So what we're trying to figure out here is this. State at least 5 characteristics. Gabby, what's up? Under F, just put second, because the way you can find it, I'll show you how to find x-intercepts a different way than what you've learned in the past. But the way you've learned in the past is second, trace, number 2 value. So under F, you would just put second, trace, 2 value, because that's how you find your x-intercepts normally, and then left bound, right bound. But I'm going to show you another way too that you can do it, which is the other one that's on there. Okay, state at least 5 characteristics that these have in common. What do they have in common? All cubic. What else? All positive what? Leading coefficients. That's also true. All positive leading coefficients because they all end up on the right, correct? They all have positive y-intercept. Someone said that. That is true. Bless you. What else do they have in common? Same range. What is the range? YER, because one's going up, one's going down, right? What else do they have the same? Same domain. What is it? XCR. How many y-intercepts do they all have? Every polynomial function has one y-intercept. Whether it's linear, it's going to cross through once. Quadratic, it's going to cross through once. Or cubic, it's going to cross through once. Okay, 2 characteristics that differ. One is what? One has a minimum negative. What about their x-intercepts? How many does the first one have? How many does the black graph have? 1 x-intercept. And the red graph has 2. And the green graph has? You can have a maximum number of x-intercepts as the degree. So for linear functions, they're degree 1. You're going to maximum have 1 x-intercept, and you're always going to have 1. Why do you have to have 1 for a degree 1 function? You'll always have 1 x-intercept. Maximum you can have is 1, but you always for sure have 1. Because degree 1 graph, arrows going opposite directions, right? It's going to have to cross through the x-axis somewhere, correct? Degree 3 follows the same rule. Degree 3, you're going to have at least 1 x-intercept because you have arrows going in opposite directions. There's no way you can draw that in order to get 0, right? However, you could draw it to get 2, where it would be like that. Or you could draw it to have 3, where it just goes right through, correct? But at maximum, I can only have 3, because degree functions, polynomials, can have at maximum the number of x-intercepts as the degree. So if it's degree 3, you can have maximum 3. Degree 2, however, have arrows going in the same direction, so that's why you can get no x-intercepts, right? Because the whole thing could be drawn above or below. But with degree 3 or degree 1, you have arrows going in opposite directions. At some point, it's going to have to cross through the x-axis at least once. So linear, it'll cross through always once, and then degree 3, it'll cross through 1, 2, or 3. Okay. And we'll skip that for now because we're doing a whole different thing on x-intercepts. A second. Okay, so this is right out of your workbook. You can open the workbook. If you don't have a workbook, you can work through this one. It's fine. I printed this off so you didn't actually have to. So if you printed it off, you didn't have to write this all out of your workbook. If you do not have your notes printed off, you're going to have to go to the workbook and look at it, which I don't know what page it is on. 343? Does it say it up here? Or at the bottom? So this is page 343 out of the workbook if you do not have the notes printed off. If you do have the notes printed off, then you can just fill it in. Okay? So try these ones out. It also gives you the window that's appropriate. Here it tells you X min should be -8, X max should be 8, X scale 2, Y min -20, Y max 20, Y scale 5. So try that out.